My wonderful viewers, you are welcome to Understanding Chemistry by Nkechi. Today's topic we're looking at calculations involving electrolysis. If you are watching this video for the first time, I've already uploaded videos on introduction to electrolysis, examples of electrolysis, Faraday's laws of electrolysis. If you watch this video, I would like you to watch Faraday's law of electrolysis, where we derive formula on electrolysis using formula method. Okay, so let's start. This question number 1. Calculate the number of Faradays or number of moles of electrons that are required to form the following during electrolysis. So we've already established that 1 mole of electron is equivalent to 1 Faraday, which is equivalent to relative molecular mass of the element. So 2 moles of oxygen molecules that are required to form 2 moles of oxygen molecule. Okay. So I have the oxygen molecule here. So remember this oxidation occurs at the anode. So I need to balance this atom. The question says 2 moles of oxygen. So I'll put 2 here. 2 times 2, that is 4. I'll put 4. Yes, I have 4 atoms of oxygen. Okay, let's check for the electron. 4 times 2 minus is 8 minus. So I'll put 8 here. So it's balanced. So how many electrons do I have here? So look at the question. Calculate the number of Faradays or number of moles of electrons. So for the number of electrons, how many do I have? 8 electrons. 8 moles of electron. 8 moles. So what are Faraday? The same thing. How many number of Faradays do I have? 8 Faraday. 2 moles of aluminum atom. So this aluminum atom, remember oxidation, reduction takes place at the cathode. So 2 moles of aluminum atom. How many atoms will I put here? 2 times 3 plus, that's 6 minus. 6 electron. So to give this aluminum is being deposited, but to be 2 moles of aluminum. So the question is, how many moles of electron do I have? 6 moles of electron is needed. It's required to deposit 2 moles of aluminum. So 6 moles of electrons. So how many number of Faradays is required to form 2 moles of aluminum atom? That's 6 Faraday. 6 Faradays. So let's look at number 3. So this is your chloride ion. So remember, for the anions, oxidation, they migrate to the anode, and the anode oxidation takes place there. So this 1 mole of chlorine molecule. So I need to balance the atom. I have 2 atoms of chlorine here. I'll put 2 here. So I need to balance the electron. I have 2 minus. So I'll put 2 electrons. So 2 minus, 2 minus. The electron is balanced. So how many moles of electrons do I have? That's 2. So 2 moles of electrons is required to deposit 1 molecule of chlorine gas. So 2 moles of electrons. So how many Faradays do I have here? 2 Faradays. Calculate the mass of copper deposited by 6 moles of electrons in the reaction represented by the equation below. 2 moles of electrons deposited 1 mole of copper. And 1 mole of copper is equivalent to 64 grams, which is relative molecular mass of copper. So 2 moles of electron deposited. So this is all writing 1 mole of copper. So that 1 mole of copper is 64 grams. So therefore, 6 moles of electrons will deposit X, I can call it X grams of copper. So when we do cross multiply, our S will be 6 times 64 divided by 2. So 6 times 64 divided by 2. So give us 192 grams of copper. So calculate the mass of copper deposited by 6 moles of the electron. It should be wrong for me. We're looking for the mass deposited by the 6 moles of copper. It should be wrong for me to say 6 moles of copper deposited 64 grams. No. So whatever you have here as the moles of electron is connected with the molar mass, relative molar mass of copper you have. If I have 2, I would have said 2 moles of electron deposited 2 times 64. If I have 3 here, 3 times 64. Okay. So question number 3. What is the quantity of electricity produced when a current of 2 amperes is passed for 3 hours 45 minutes? So remember, the quantity of electricity is equals to current times time. That's IT. So current times time. So we're giving current. Our current here is what? Current is 2 ampere. Time. Your time has to be in seconds. But here we're giving 3 hours 65 minutes. So we're going to convert this time to seconds. So this is 3 hours. Because students find it challenging. Even though it looks simple, but students do fail it. For example, if I convert hour to second, just times 3 times 60 times 60. If you're converting minutes to second, just times it by 60. But some, I don't know if it's out of tension, they will just divide and make mistake. So this is my hour. What's the real conversion? If you want to convert hour to minutes, 60 minutes makes 1 hour. Then I want to convert minutes to seconds. 60 seconds is equals to 1 minute. So hour will cancel hour. If you know that correct, hour will cancel hour, minute will cancel minute. You're left with seconds. So I have 3 times 60 times 60. So remember, I also have 45 minutes plus 45. If I want to convert 45 minutes to seconds, 60 seconds is equals to 1 minute. So plus 45 times 60. So your exam, it might not really do it like this, but if you are confused, anytime you're confused, you just do it this way, anytime you're confused. But then you just put 3 times 60 times 60 plus 45 times 60. So what do we have? So we have 13,500 seconds. So quantity of electricity is equals to, current is 2. 2 times 13,500. So I have 27,000 coulombs. So put the units. Calculate the mass of copper formed when 900 coulombs of electricity is passed through copper 2 tetraoxide of a C solution. Okay. So looking for the mass of copper deposited. So let's go to write the equation for the reaction. So this copper 2 ion accepting 2 electrons to deposit 1 mole of copper. So calculate the mass of copper formed. So there are 2 methods. We can use formula method. So let's solve this one first. What is this formula method? All right. 2 moles of electron deposited one mole of copper. 2 moles of electron is equivalent to 2 Faraday. So 2 Faraday, and 2 Faraday is what? Okay, so 1 Faraday is 965,000. So 2 times 96500 coulomb deposited one mole of copper. 1 mole of copper is what? 64 grams. Deposited 64 grams of copper. Therefore, 900 coulombs. 900 coulombs will deposit X grams of copper. So I want to say something. The Faraday, 2 moles of electron or moles of electron Faraday goes in line with the relative molecular mass of the copper. This is the quantity of electricity that is needed. This one is the quantity of electricity goes in line with the mass deposited. So that's the format. I cannot bring this 900 and put here. No. So the Faraday, if you have 1 Faraday, 1 times 965,000 goes in line with the relative molecular mass of that element. Then the quantity of electricity always deposits the mass. Quantity of electricity goes in line with the mass deposited. So that's the format. So S will now be, if we multiply this times this, divided by 2 times 96500. So X is equals to 0.3 grams of copper. So the mass of copper deposited is 0.3 grams. That's what is deposited. Okay, let's use the formula method to solve this thing. So we're using formula method. Remember, Faraday's first law of electricity, mass varies directly at quantity of electricity. So when we put the quantity sign, this is what we have. Mass varies directly proportional to the quantity of electricity. So if we remove this, you put the chemical equivalent, which is Z. Sometimes we put E. So all over Q. Remember, Q is also Q is equivalent to what? IT. But here we have anything to do with time and the current. So remember, I mentioned that first Faraday's law, the video I did before this one, that Z, the chemical equivalence is what? Relative atomic mass divided by number of Faraday. Number of Faradays. That's what this Z means. So when I substitute this in here, so M is equals to capital, since Z is relative molecular mass, atomic mass, so capital M is the relative molecular mass divided by number of Faraday. So that number of Faraday, since I have 2, so that number of Faraday could be 2, it could be 1. So I can use, sometimes people they use Z to represent it. Some they use C. Some they use N. Okay, I can use N. So this one shows number of Faraday. So this formula we're going to use, formula method. So mass, you're looking for the mass. What's the molar mass of copper? The molar mass of copper is 64. What's the quantity of electricity given? So 900. So what's the number of Faraday we have here? So have 2. This is 2 moles of times 96500. 0.3 grams of copper. So whichever one is it's okay for convenience for you. Use the formula method, but ensure I don't make mistake in the formula. So this is the formula method. If you are given current and the time, instead of this Q, you put IT. Will be a current of 1.5 amperes pass through a solution of silver 3035 solution to deposit 0.1 mole of silver. So the relative molecular mass of silver is 108. 1 Faraday is 9600 coulomb to mole. So this is the equation of the reaction. So as you can see, 1 mole of electron equivalent to 1 Faraday, which deposited 1 mole of silver. And 1 mole of silver is equivalent to, is equal to the relative molecular mass of the silver. So look at this question. We are not asked about the mass. If you ask to find the mass, we have said, okay, it would have been 1 Faraday, 1 times 9600, deposited 108 grams. So this mass is not given to us, and we are giving mole. So we're using mole since 1 mole is equivalent to relative molecular mass. So we'll be using mole instead of the relative molecular mass. Okay. So 1 times 96500 coulomb deposited 1 mole of silver. So therefore, so the quantity of electricity will now deposit this mole. So this quantity of electricity, we don't know it, but we are giving current. We are asked to find time. So it's either I told you doing this. Either I say, okay, the S coulomb deposited 0.1. Whatever my S is, which is the quantity of electricity, it will now be IT. So I'll make this T, so the formula. Or since current times time is the quantity of electricity, so current is 1.5. So now the 1.5 times T coulomb we deposit 0.1 mole of silver. So we're going to make this T, when we multiply, we make this T instead of formula. So T will now be this times this divided by 1.5. So 96500 times 0.1 divided by 1.5. Okay, using the formula method, we establish that mass is equal to chemical equivalence all over Q. That's quantity of electricity. And quantity of electricity is IT. So M is equal to, this electrical equivalence is molecular mass divided by number of Faraday. So number of Faraday, some textbooks they use Z, some they use C, some like as C. So which other one we can use some like as ZF. So we are looking for T. So we need to make T instead of the formula. So if T is to be instead of the formula, it will be what? T is equals to MZF all over MI. So note that molar mass over molar mass is equal to what? Is mole. Number of moles is equal to mass over molar mass. So T will now be what? Number of moles. I use N to represent number of moles. ZF all over current. So we're going to use formula to do what? To find our T. So T is equals to, what's the number of moles here? 0.1. 0.1 times this there is the charge on the electron, the charge. So 1 is what I have here. 1 times Faraday is 96500. So what's the current? Current is 1.5. Same thing. 6,433 seconds. So which other way you want to use? Why I did not use the other one I did? I use N as number of moles for that, but if I use N and also use number of moles, it's going to confuse. So I use Z as a charge. So if you ask to find the charge, at times you can ask to find the charge on the element, the charge. Remember, the valency, this charge here is what I have here. If the charge is 2 plus, that's what I do 2. So if you ask to find the charge, you just make this Z sort of formula. You have to make your Z sort of formula. If you want to use the other method, you just the other method, you just say, remember, just say maybe Z times 965,000, which is equivalent to relative molecular mass, quantum of electricity, give you the mass, and at the end you are looking for the Z. So when you find the Z, you put, if the Z is 3, you add, got the acid charge, you put plus 3. Because the cation metals are positive charge, you put plus 3 or plus 2, depending on what you have. The process of dilute H2SO4, 0.08 mole of electrons were passed. What volume of gas was produced at the anode? So we are given that the molar volume of a gas at STP is 22.4 dm3. Let's start the equation for the reaction. So remember at the anode, during the process of dilute H2SO4, the hydrogen ion migrates to the anode and becomes discharged as oxygen. So 4 hydrogen ion. So it's always good to know how to write the equation for the reaction. So you can see, it's good to know when to use Faraday. This is 4 moles of electron, which is equivalent to 4 Faraday. I want to be using Faraday because there's no quantity of electricity given to me in Coulomb. So all I use 4 moles of electron produce 1 mole of oxygen. 4 moles of electron produced 1 mole of oxygen gas, and 1 mole of oxygen gas at STP is 22.4 dm3. If I know I ask to find the mass of oxygen, not at STP, the mass, I will use produce 32 grams of oxygen. So at STP produce 22.4 dm3 of oxygen. So therefore 0.08 mole of electron will produce, so I like to use X dm3. Let's find what the S dm3 of oxygen. Let's find what our S is. So S is equals to 0.08 because multiply times 2.4 divided by 4. So when I do that, you're getting 0.448 dm3 of oxygen that was being produced. So I'm going to look at Faraday's second law of electricity calculation. What quantity of copper will be deposited by the same quantity of electricity that deposited 9.5 grams of aluminium? Remember the second law of Faraday's law of electricity: 2 electrolytes, 2 electrolytic cells connected in series. So that's what you see here. So the same quantity of electricity being used for 2 of them. So what quantity of copper will be deposited by the same quantity of electricity that deposited 9.5? So I'm going to use 2 methods to solve this. So anyone that's convenient for you, you're making use of it. Okay. So the first method, mass of copper deposited all over mass of aluminium deposited equals to, so what's the chemical equivalence of copper all over chemical equivalence of aluminium? So chemical equivalence of copper, Ce of copper of any element is equals to the relative atomic mass of that element divided by the valency of that element. So the one of copper will be What's the relative atomic mass of copper? 64. What's the valency for copper? That's 2. So that's when you give it as 2 grams, 32. That's all you need for it to give it 32. So the one of aluminium will be 27 divided by the charge, and the charge is 3. So the 7 divided by 3. So what's the mass of copper? Mass of copper, we are looking for it. So let it be S. So mass of copper all over. Mass of aluminium is 9.5. What's the chemical equivalence of copper? It's 32. What's the one for aluminium? 27 divided by 3 is 9. So mass of copper 9.5 grams times 32 divided by 9 is equals to 33.8 grams of copper. Okay, it's already mass of copper there. So this equals to what? 33.8 grams. So let's look at another method of solving this. So let's put down our formula. It's good to put this. Okay, I'll give aluminium first. Let me start with aluminium. Okay, look at this. 3 Faraday. 3 times 965000 coulomb deposited. What's the molar mass of aluminium? That's 27 grams. So of aluminium. So therefore, 3 Faraday, this 3 Faraday deposited 1 mole of aluminium. So 3 times 965000 coulomb deposited 1 mole of aluminium, which is 27 grams of aluminium. Therefore, the quantum of electricity is not given. So that's what we want to find. So therefore, the S coulomb, which is the quantum of electricity, we deposit 9.5 grams of aluminium. So what's my S? The S I'm finding is the quantity of electricity, which is 3 times 96500 times 9.5, and was multiplying divided by 27. So 10186 1.1 coulomb. So this is the quantity of electricity. So the same is also applied for what? For copper. So I find the quantity of electricity to be 10186 1.1. So let's find the mass of copper that will be deposited with this quantity of electricity. So for copper, so I will say 2 times 2 Faradays, 2 times 96500 coulomb deposited. What's the molar mass of copper? 64 grams of copper. Therefore, 10186 1.1 coulomb we deposit. So we deposit X grams of copper. So by the time you do it, your S will be, what will be our X? So X will be 10186 1.1 times 64 divided by 2 times 96500. So let's 3.8. So then 3.8 grams of copper. So which method is easier for you? You make use of it. So you want to use the one of mass of copper equals to chemical equivalence of copper divided by the aluminium all over chemical equivalence of aluminium. So always remember that the chemical equivalence of copper or that element is relative molecular mass divided by valency. Remember the valency. Alright. The cost of discharging 6 grams of intervalent metal X from each sort is 200 naira. What is the cost of discharging 9 grams of a trivalent metal R from each salt under the same conditions. So yeah, given the molar mass, relative atomic molecular mass of X is 64, R is 27, then 1 Faraday is equal to 96500 coulomb. So let's start. So for the divalent metal X, so X 2 plus affected 2 electrons to the X. So the cost of discharging 6 grams of a divalent metal X from each salt is 200 naira. So how many Faraday? 2 moles of electron, which is equivalent to 2 Faraday. And 2 Faraday is 2 times 96500 coulomb liberated. So remember, I also said that the Faraday goes with the moles of electron goes with relative molecular mass. So liberated 64 grams of X. Therefore, I don't know what this is. So Q coulomb, the quantity of electricity, we don't know it, will liberate 6 grams of X. So what is the quantity of electricity? It will be 2 times 96500 times 64 divided by times 6 divided by 64. 18094 coulomb. So we're gotten the quantity of electricity is 18094. So 1894 coulomb cost 200 naira. Therefore, 96500 coulomb will cost X naira. So what's our X? 96500 coulomb times 200 divided by 1894. So our S is what? This S is 1067 naira. So it means that 96500 coulomb will cost 1067 naira. So 96500 coulomb is equivalent to 1067 naira. So you can swear, remember, 96500 is something as 1 Faraday. So it means that 1 Faraday is equivalent to 1067 naira. So this is the equation of the reaction for the trivalent metal. So 3 Faraday, which is 3 times 96500 coulomb, liberated. What's the relative molecular mass of the trivalent metal? 7 grams. So therefore, this quantity of electricity, let's see what we have here. So therefore, the quantity of electricity will liberate. So the mass is given, and it's given as 9 grams. 9 grams of R. 9 grams of R. So what is our Q, the quantity of electricity here? So it will be 3 times 96500 times 9 divided by 27. So when you multiply this and divide by 27, it will give us 96500 column. So it means that the quantity of electricity that is required to create 9 grams of R is this 96500 column. So which means, remember also that 96500 column is equivalent to 1067 naira. So which means the cost of discharging 9 grams of a trivalent metal is 1067 naira. Since the quantity of electricity here is 1 Faraday, which is 96500. So the cost will also be what? This. So the cost of discharging a trivalent metal is 1067 naira. A quantity of electricity was passed through 3 voltmeters in series for 1 hour 30 minutes. In one electricity cell, 5.1 grams of silver was deposited from silver translucent solution, AgNO3. In the second cell, hydrogen gas was evolved from dilute H2SO4, and in the third cell, aluminium was deposited from aluminium translucent 5 solution. Calculate the quantity of electricity passed, the current passed, the volume of hydrogen collected at 30 degrees Celsius and 740 millimeter mercury. D, the mass of aluminium deposited. When it's a question like this, don't be afraid. It's not hard. So take it step by step. Alright. So this question we need to copy it down, and because I'll be clearing the board. No space. You can see no space for me to solve. So I'll clear the board and solve it. So the first one is the quantity of electricity passed. So how do we get the quantity of electricity passed? For one, okay, look at this. This is the time, 1 hour 30 minutes. So in 5.1 grams of silver. So I know the mass of silver. Since I know the mass of silver, remember any quantity of electricity I have here. When I get a quantity of electricity, I will use it for all of them, because when it said I collected the series, they use the same quantity of electricity. So since I know the mass of silver deposited, so I can get the quantity of electricity. So let me clean. So this is equation for the reaction. This is equation for the reaction. So silver ion. So this is equation for the reaction. So 1 Faraday deposited 108 grams, 1 mole of silver, which is 108 grams. So 1 times 96500 column deposited 108 grams of silver. So therefore, you can use your formula method to find the quantity of electricity, or anyone that will be easier for you. So therefore, S column, I know that the quantity of electricity goes with the mass deposited. So therefore, S column will deposit 5.1 grams of silver. So what's our S? So S will be 96500 times 5.1 divided by 108. So I'll be having. So the quantity of electricity here is. So this is the quantity of electricity. Then column. So B, calculate the current passed. We have to find the current that is passed. Okay. Calculate the current that is passed. So for the B, remember quantity of electricity is equals to current times time. So our time is given. T is equals to, let's say it's 1 hour 30 minutes. So 1 hour. So the 1 times 60 times 60. 1 hour 30 minutes plus 30 times 60. So let's check our time. So having known our time, we can be able to calculate. So I will make current, so the formula, which is Q divided by time. So what's our Q? 4557 divided by 5400 seconds. Okay, 0.5 0.84 ampere. So this is the current. So I'm going to look at C. C is find the volume of hydrogen collected at 30 degrees Celsius and 740 millimeter mercury. Okay. So C, the volume of hydrogen collected. Let's look at the volume. So for the hydrogen, so this is the question for the hydrogen. So you can see 4 moles of electron or 4 Faraday produce 2 moles of hydrogen gas. So 4 times 96500 coulomb produced 2 moles of hydrogen. And you know, 2 moles of 1 mole of a gas at STP is 22.4. So I have 2 moles, 2 times 22.4 dm³ of hydrogen gas, hydrogen molecule. So therefore, the quantity of electricity, when they're going in series, they use the same quantity of electricity is being applied for all of them. So therefore, 4557 coulomb will produce X dm³ of hydrogen. So what's my X? 4557 times 2 times 22.4 divided by 4 times 96500. So my X will be what? Let's 0.53 dm³ of hydrogen. So that's the end of the question. So what I have here is 0.53 dm³ of hydrogen. So remember I said the volume of hydrogen gas at 30. So we're going to convert this thing to that. We're going to convert this dm³. This is 0.53 dm³ at that temperature, 30 degrees Celsius and pressure of 740 millimeter. So we're going to be using the general gas law to solve it, but I want to convert this volume to that temperature at 30 degrees Celsius and the 740 millimeter mercury. So using general gas law, P1 V1 all over T1 is equals to P2 all over V2 all over T2. So what's our P1? This is the volume at STP. So P1, pressure at STP is 760 millimeter mercury. So what's our V1? That's the one at STP, which will got 0.53 dm³. So what about T1? Standard temperature 273 Kelvin. So P2 is giving 740 millimeter mercury. What's our V2 is what we are looking for. T2 is what? 30 plus 273, which will give us the 303 Kelvin. So we're looking for V2. Let's make V2 set of formula. So V2 is P1 V1 T2 all over P2 T1. So what's our V2? What's P1? So 760 times 0.53 times 303 divided by 740 times 273. So what's the answer? Calculate the mass of aluminum deposited. So this is the equation for the reaction. This is 3 Faraday, 3 moles of electron, which is 3 times 96500 coulomb deposited 27 grams of aluminium. So 4577 coulomb, which is the quantity of electricity, will deposit X grams of aluminium. So what's our X? When it was multiplied, 4557 times 27 divided by 3 times 96500 coulomb. So the mass of aluminium deposited is 0.43 grams of aluminium. Right. We've come to the end of today's video, where we have learned calculations on involving electrolysis. I would like you to practice more exercises. What have we done now You can not attempt any calculation involving electrolysis. It's very simple for you. Okay. So next video I will upload is uses of electrolysis. Not just it's used for electroplating and the extraction of metals. Beyond that, I will give a detailed explanation of the uses of electrolysis. And after that, we'll go into electrochemical cell and electropotential. Thank you for watching. I would like you to subscribe to this channel, like and share to your friends so I can get to more people. Thank you for watching. Have a great day. Bye.